Hello everyone, and welcome back to this channel. In this video, we will be solving the day 6 of the March Leetcoding challenge, which says that short encoding of words. So, a valid encoding of an array of words is a reference string S and an array of indices such that words.length is equal to indices.length. The reference string S ends with hash character, and for every indices the substring is starting from indices and up to the next character is equal to the word. Given the array of words, return the length of the shortest reference string possible of any valid encoding of words. So I'm pretty much sure that most of you might have not understood this question. Actually, the phrasing of this question is not quite good. Maybe LeetCode can change this problem description. So I'll just quickly explain you what the problem tries to say. So here we have been given a list of words and we have to form a string such that from this particular string we should be able to get all the elements in the words array. So the valid encoding is this one. So from here we can get time, that is time here. Similarly, me can be formed me and a hash, bell, bell and an hash. So let us take a let us look at how exactly we can solve it. So basically what we need to find is that is there any way we could find that okay, me is present in the other elements of that array, right? Here me is present here, right? Me. So once I have the encoding for time, I also have the encoding for me. So I do not have to consider, I don't have to make a different encoding for this one. So that is the pretty much the gist of this problem. Like we have to find if there is a string which completely overlaps another element in that particular array, and also it should be at the ending, right? It shouldn't be, let's say, timer. If it is timer for some reason, so then that is the point wherein we have to create a encoding for me as well, because me is not the ending one, right? It should also end with a hash. So let us check how can we solve this particular problem. So I have taken this first test case. So yeah, so this is the first, the list which we have. I have converted into a set, and I think the main crux of this problem is to find if somehow me like, is there any valid encoding for that, right? So once I have it, I don't have to worry. So how will I solve this is that first I'll take the first element from the list, that is time. Then I'll take its particular substring starting from the first index. So IME is the first substring. I will check if this is present in the set or not. So IME is not present in the set. So I'll take the next. So I'll take the next uh, substring, that is ME. So if we check ME is present in the set, so we will remove this thing from the resultant set. Now the next one is E. So E is not present in the set, right? So we are done with the first element. We will come to the second element, that is ME. So again, is E present in the set? No, it's not present in the set. So I'll just move on to the next item. So bell. So for this bell, I'll take substring from the index 1. So that is ELE, E double L. So is this E double L present in the set? No, it's not present. So I'll take the next substring, that is double L. Is double L present in the set? No, it's not. Is single L present? No, it's not. And so on. So I think after this, I have found found the actual elements which requires an encoding, right? So after that, my resultant would be, so my result would be time hash bell hash. So this would be the resultant encoding for this particular element, and also we just have to give the length of it, right? So it would be 4 and 4, that is 8 plus 2, that is 10. So the length of this one would be 10 in that case. So that is what I have to return. So I return 10. So I think you should be able to understand the solution for it. So let us go to the code part. Yeah, so this is the code in Java which we have written. So first we are converting the number of words into a set, and then what I'm doing is that I'm traversing through each and every element of the words array. Okay, so inside, for each and every element, what I am doing is that I'm trying to find a substring, right? A substring from index 1, and if it is present in the set, I will remove it. So this is the same thing which I had explained it here, right? And once that is done, I will traverse through all the strings in the set, and I will take the resultant length plus 1. Here plus 1 is for the hash character, and then I will return the result. So I think the code is also easy to understand. Once you understood the explanation, this code is very easy to get. And talking about the time and space complexity, so the time complexity is n into k square. So let me explain you that. So here, if you check, this one would travel with this one will will loop for n times, right? And let us say if for every element n, this is the k, that is there are k different substring. So for every k, we are also calculating the substring of it, right? So substring would again take k. It would take k time to calculate the substring, whereas removing from a set would be done in a constant time. So this is how the time complexity would be n into k square, and also the space complexity would be order of n, because in worst case we would be uh, keeping all the elements in the set. So yeah, that is pretty much about it. And thank you for your time. Thanks.